Well, hello everybody. My name is Pat Dunn, and I'm a peer mentor for the Biostatistics 6125 and 8125 courses. And tonight we're going to do a study review for the final exam. We are within days of the end of the quarter, and I'm sure you're all very happy about that. You'll probably be especially happy when you are finished with your final. I can appreciate that. I'm going to kind of do a general overview of some of the content we've gone through in the course, and I'll try to specifically highlight things that you'll see on the final. We can't go over the final questions. That's for you to do on the final, but we'll do some of the similar problems like we've done in the weekly assignments. So the content, like I said, is to review the final. Couple of key things going over the decision tree. I know you just had a quiz, and the decision tree was kind of an important part of doing well on that quiz, and it'll also be important for you to do well on the final. Talk a little bit about creating graphs in SPSS, a little bit about creating values based on some of the tests you've learned how to do, and what I'm going to try to do is demonstrate a few of those. Take a look at some of the interpretation keys, and then again we'll open this up for Q&A as much as possible. So some of the keys to doing well on the final. Number one is to be organized. Take your time and literally take it one step at a time. Take it one question at a time, and kind of point by point. One thing you'll notice is that the final exam is very similar to the weekly application assignments. It's not like the timed quizzes that you've had throughout the quarter. So I strongly encourage you to go back through your homework, take a look at the step-by-step guides. You may want to redo some of those before you do your final. Take a look at your graded homework. Again, look at the feedback you've received from your professor, and then also look at the other resources. Look at the PowerPoints. Also take a look at the videos that show you how to do some of the SPSS tests. Those can be very helpful in producing some of those tests. Take a look at how the graphs are constructed. Go back and review the decision tree. Take a look at the interpretation of your results. Look at some of the guides, especially the null hypothesis. Remember, it's a 5-step process for hypothesis testing. So literally go through all 5 of those steps. Explicitly state your null and your alternative hypothesis, just like is outlined in the book and in the step-by-step guides. Review, confidence intervals. It's very important to understand terminology, to know the difference between, for example, prevalence and incidence. Those are kind of key concepts. If you're a public health student, this is kind of core foundational work that you really will use throughout your career, and you'll definitely use it in other coursework in your curriculum. So you're going to have to learn this stuff anyway. I know for a lot of people, statistics and biostats are not your maybe your favorite class, but the concepts you're going to use throughout your career. So let's take a look at the decision tree. And I have the decision tree loaded up here. So you really want to go from left to right on this decision tree. So you have a statistical test that you're being asked to perform. The first question is, what type of test is this? Is this a descriptive test? Are we looking for differences between or among groups? Or are we looking at relationships between and among variables? So if it's a descriptive, are they numerical, where you can compute a mean, a median, a standard deviation? or are they more categorical? Are you looking at frequencies and charts? If we're looking at difference testing, ask yourself, are we looking at one group, one sample, or are we looking at multiple groups? And remember, if you're looking at two groups, you can use the t-test. If you're doing more than two groups, then you have to go with the analysis of variance, or referred to as ANOVA. Okay. Again, within the t-test, remember that there's different types of t-tests. There are paired t-tests. There's also independent sample t-tests. And again, ask yourself, what kind of variables are we looking at? Do we have numerical? Are they categorical, ordinal? And if they're not numerical, then you may have to go with a non-parametric test, like a Wilcoxon or, for example, a Mann-Whitney, and know how those are all related to one another. If you're looking at testing, and another one, if you're looking at maybe frequencies as opposed to numbers, then you may be looking at a chi-square goodness of fit test compared to a t-test or analysis of variance. When you get down to relationship testing, if you're testing two variables, then you're looking at a correlation coefficient. You may also be doing linear regression, where you have a dependent and an independent variable. If you have multiple variables that you're looking at, and you have a multiple independent and one dependent variable, then you're looking at a multiple linear regression. And again, if you have if the variables are not numerical, if they're, say, for example, dichotomous variables, then you may be looking at a multiple logistic regression. Stop there for a moment. Can you hear me now? I think I had myself muted. Sorry about that. So we were talking about the creating the 2x2 table. So you have the exposed and the non-exposed cases and controls. Okay, so if you go to, remember back to week 3, we have on the first page here you have the odds ratio, and it's going to be, and so just again in the final, go to this, refer to this, A over B divided by C over D. That's going to give you your odds ratio. Oh, I'll go back to the graphs in a second here. And then the relative risk, it's the same data, but it's going to be A over A plus B, and then C over C plus D. All right, I'm going to go back to the graphs here because I think you probably saw what I was doing but weren't hearing my voice, and I apologize for that. So, and I have everybody unmuted. Can you all hear me? Yes, okay, good. Okay. So, to produce a graph, so again, I'm going to select my table. I'm in the alcohol underscore bladder ca.save file. And what I'm going to do here is I'm going to be in the data view. I have analyze and graphs. I'm going to mute everybody again, except me. I think you can still hear me, correct? Okay, so for the graphs, you're going to select graphs. You're going to go to Legacy Dialogues, and you're going to select the type of graph. So in the example I had, we have the scatter dot. Select Simple Scatter, and click Define, and you're going to move your variables just like what's asked for in the step-by-step guide. So I'm looking here in problem 2.1. Use this as an example. So I have age in the X, or in the Y, and I have income in the X. And I'm going to select OK, and SPSS will produce my scatter dot for that example. Does that help? And what you'll want to do then is go back to your step-by-step guide, problem 2.1, and look at all of these different options that you have for producing different graphs, and literally just model these, for what you're asked for in the final exam. Okay. So we're going back to let me review that really quickly since you probably missed some of the audio. So a couple of things we're going to look at too are producing descriptive statistics, looking at the odds and risk ratio, confidence intervals, and then different types of tests that are available to you. Okay. In the odds, so you have the odds ratio and the risk ratio, and they're both based on a 2x2 table. So the only difference is the equation that you're going to use. So you will want to go to the week 3 step-by-step guide and use this as a model for calculating your odds ratio. Okay, so just remember A, B, C, and D, plug your values in, do the calculation, and you'll get your result. Next one is we have the cumulative incidence. This is the total number of new cases or injury cases during a specific time period. Okay, so it's the cumulative incidence is the new cases over the total number of people at risk. Okay, so if I'm in year 1 and I have 100 people at risk, so if you're looking at things that can only be males or females, then you have to look just at the group at risk. But if I have 100 people at risk and I have 10 new cases, then my cumulative incidence is going to be 10%. Okay, what the person time is going to do is it's going to estimate the actual time in person years. So that's where you start getting into quarters of years or halves of years to do that calculation. So, and again, just review the information on the incidence density. We'll go back. I have everybody muted again for just to reduce the ambient noise. The other thing is just to remember, just in general, to understand the difference between prevalence and incidence. So prevalence is the total number of people at risk. So the prevalence of high blood pressure in the United States is like 67 million Americans. That would be the prevalence. If we're looking at the number of heart attacks in a year, if there's 1 million heart attacks a year, that would be the incidence. So make sure you understand the difference between incidence and prevalence. Okay, and now when you go into interpretation of your data, just a couple of things to keep in mind. First of all, again, use your hypothesis testing. When you're looking at your sample, know what is typical and what is, kind of a deviation from the norm. Take a look not only at the means, and the averages, but look at the variability. How much does the data vary throughout the measurement? How are the data distributed in relation to other variables? So if one variable goes up, is the other also going up, or is it going down, or not changing at all? Remember to look for statistically significant relationships, and you do that through your p-values. You also do that through your confidence intervals. And again, report the the normality, the variances, all of that stuff is helpful and important. Okay, we're going to go through a couple of examples here. I've already done the descriptive statistics. Now, if I go, try not to go too fast on this, and be sure send me a chat if you have a question, if you need me to stop through this. So on problem 4.2, we're looking at frequency. So we want to create a frequency table for education. And this is in the EDU. Smoke. So again, if you're forgetting how to do this, use the step-by-step guide. So you're going to go Analyze, Descriptive Statistics, and Frequencies. It asks for the edu variable, so you put the edu variable. So they're always going to start over here. Just drop and drag into the variable. You can select other statistics, so if you need a mean, standard deviation, any of these other variables, click Continue and click OK. And then I get my frequencies built on this table here. Question, will these slides be posted? I'm recording this video, so I'm going to produce a recording of this video, but I can also send this to the other peer mentors, and they can post it in your study groups if that would be helpful to you. Okay, the next one, let's look at t-testing. So we have in week 5, we did a paired t-test. So a paired t-test, remember, you're going to have a before and an after. Pardon me there, I had to close my door. I was hearing some extra noise. But again, go back to your guides here. So you're going to go Analyze. You're going to go Compare Means. Okay, and we're doing a paired t-test. Okay, and I have my variables. I have after and before selected in my variables 1 and 2. Okay. Not much else here. We have confidence intervals of 95%, and I'm going to select OK. And now I have a t-test. And so what are you looking for on your t-test? You're looking at your significance level, 0.003, which is less than 0.05, so we have a significant relationship. We also have confidence intervals that do not cross 0. Okay, they go. The lower limit goes from 4.9 to 19. Okay, so what that means, what does that mean? There was an average of a 12-point shift from before to after in this sample, and I forget exactly what the sample was looking at. I don't know if that was, who knows, 38 to 26. So it might have been a body mass index. It could have been an HDL cholesterol. Who knows? Okay. But what this means, it's really important that you understand what this means. What this means is if you did this study again with a different set, so you had 16 people in this study. If you did this again with another 16 people, there's a 95% chance that your mean is going to be within this range here. Okay? There's only a 5% chance that it's going to be outside of this mean. So if you do this again and you have, let's say, a 25-point shift, that would be significant, okay, because it's outside of this confidence interval. Next one is the independent t-test. So again in week 5, but with a different data set. We had the histidine data set. Okay, and what we're looking at here is, again, the same thing, go Analyze, Compare Means, Independent t-test. Now what you have to do here, you have a test variable you're going to select, and you have grouping variables. Okay, so when you select a group, it now is going to ask you to define your groups. If you notice here, the groups are 1s and 2s. Okay, if those were males and females, M or F, or some other variable, SPSS needs to know what to look for. So when you define your groups, you tell it group 1 is 1, and group 2 is 2. Click Continue. Check your options, 95% confidence interval. Click OK. And now you have your independent t-test. And again, what are you looking at? You're looking at, is there a significance level, and you're looking at your upper and lower. And what you're looking at here is your significance of 0.386. That, I'm sorry, the two-tailed test here is 0.038. Okay, so again, this is less than 0.05, and your confidence interval does not pass through 0. So again, you would find this to be a significant relationship. The next and the final kind of t-test is a one-sample t-test. You did this in week 6. With the alcohol .sav. And so again, you're going to analyze, compare means, and one sample t-test. Now because it's one sample, and if you go back to your problem 6.1, it said our hypothesis was that the value would be 36.5, and it wanted to know if the mean of 37.69 was significantly different from 36.5. Okay, so again, going here, so you put in the test value 36.5, 95% confidence interval, click OK, and your output. So this time, again, you have a two-tailed significance of 0.009, less than 0.05, and you have confidence intervals not going through 0. All right, the next one is the chi-square. That was also in week 6. The edu.smoke, and let's look at that. Problem 6.2. Okay, so with the chi-square, you need to understand the expected frequencies. Okay, so we have them listed here: 20, 25, 25, 20, and 10. So when we go here, we're going to go analyze. We're going to go non-parametric test, because the chi-square is a non-parametric test, and we're going to go chi-square. You're going to select your variable, edu, and I've already typed these in, but just to show you how this works, because this can be a little tricky, you have to put in your variables. So you can either say they're all equal, or if you know that they're not all equal, they're based on this table here, then what you do is you type them in. So 0.2 and add, 0.25, add, 0.25 and add, 0.2, add, and 0.1 and add. Now it's also critical that these all add up to 1, and you get your observed versus your expected chi-square. And you have a significance level here of 000, which means, again, that number is less than 0.05. It just means that the number is probably several decimal points out. So you do have a significant relationship there as well. Everybody doing okay? All right, we'll move on. The next one are the crosstabs, very similar to the chi-square. We're going to look at the asbestos data set. And we're going to pull up problem 7.1. So we were looking at the relationship between asbestos and lung cancer in this example. And the way to find the crosstabs: analyze, descriptive statistics, crosstabs, and we have and it tells you here, if you're not remembering, it's going to tell you where to put the asbestos in the rows and the lung cancer in the columns. So I have those set. I need to go here and look at my options. It asked in here to select observed and expected, which I've already done. And I'm going to click OK. And now I have my cross tabs table from this data set. Okay, the next one is again in week 2 is the analysis of variance. We're going to go to the smoke._BW data set. And if you notice here, we have only 2 variables, group and weight, but we have different categories. We have group 1, 2, 3, and 4. Okay, so we're going to go analyze. Again, we're going to go compare means. We're going to do a one-way ANOVA. I already have my variables selected. I have my weight in the dependent list, and my grouping factor is group. One thing you're going to need to understand and remember with ANOVA is because there's 4 groups, the only thing the ANOVA is going to tell you is if there was a significant difference among all 4 of these groups. It's not going to tell you directly where that significance was. You have to do some additional tests here. So first of all, you're going to do descriptive. You're going to do the homogeneity of variance test. And you're also going to do some post hoc tests. And in this example, it asks for the LSD and the Bonferroni post hoc tests. You're going to click Continue, and you're going to click OK. And so what do we have here? We have our ANOVA. We have our descriptive statistics. We have our test for homogeneity of variance. And what that means is that the significance level is 0.5, which means there was not a significant difference in the variance among these groups. And that's a good thing. If there is a significant difference, then you have to revert to some other tests, like maybe some non-parametric testing. But so this test passed because it was not less than 0.05. Now we have our ANOVA. We have a significance level of 0.42, which is less than 0.05. So we have a significant finding, but we still don't know where the differences lie. We did the post hoc tests here, and we found, and we're looking at, so we have LSD on the top, Bonferroni on the bottom, and this is just going to go through each of these examples. Okay, so we have non-smokers and ex-smokers. We have a significance of 0.901 that is not less than 0.05, so that's not significant. And we're confirmed by that with the confidence intervals going through 0 from a negative to a positive. So it did not find a significant relationship or difference between these 2 groups. But if you go down to, for example, ex-smokers and those who smoke more than a half a pack a day, the significance level is 0.26, which is less than 0.05, and our confidence intervals do not pass through 0. So this relationship here is significant, or this difference here is significance. Had we done the graph with this, which I believe in the example it asked for the graph, you would also see this difference graphically as well. All right, I'm going to move on to the correlation, and that's in the sodium and blood pressure group here. So again, we have a data set. We're going to go analyze, correlate. We just have 2 variables, so we're going to go bivariate. I've selected sodium and blood pressure. No other options need to be selected there. Click OK, and I have a correlation of 0.92. Now let's say we want to do a linear regression instead of a correlation. You're going to go Analyze. You're going to go Regression, Linear Regression, and you're going to select your blood pressure is your dependent variable. Sodium is your independent variable. Okay, and again we have other options here. I put in the R square, and I have my decisions there. I'm going to click OK. And now we see we still have a correlation of 0.92. It's our same data, so that should not have changed. We have an R square, so this number squared, which tells us our variance. And then we're looking again for significance, and we see that there's a significant relationship between these two variables. And when we do an ANOVA to compare these two, we also find a significant relationship here. All right, I hope everybody's doing okay, still with me. Everybody's still on. I'm going to unmute you. Anybody have any questions?
No.
Okay, we're getting close to the end here. Put you back on mute. All right, what about... Okay, we talked about the homogeneity of variance. There was a question about confounding in regression analysis. So how do you know if we have a confounding variable? So a couple of things you need to look at. So number one is if you add another variable to the regression, this is in a regression equation, does it change the significance? So did it go from not significant to significant, or the reverse? Another one is, does it change directions? So did it go from a positive relationship to a negative relationship? Okay, so those are some things to consider. I think there's a question about confounding variables, and confounders are kind of a confounding concept. You might need to just read, look in the book and try to get a good grasp or handle on that. So we actually have made it all the way through. I'm going to go here quickly to the resources. We do have our stats support. There's a couple of other websites. When we send this PowerPoint out, you can see those as well. I'm going to go back here to question and answers. I'm going to unmute everybody. Any questions that I can help you with? Okay, I'm going to take that as a good sign. I know you're all very close to the end of your term. I'm sure everybody's very happy about that. I'm sure you'll be even more happy when you're finished with your final. I want to wish everybody good luck on that. Know that there is life after biostatistics, so you will make it. And with that, I think I will wrap up the session. I'm not sure which courses you're all in, so I'll send the recording back to our peer mentor group, as well as the PowerPoint. So if you're really needing to review any of this specific information, you'll want to follow up with whomever is the peer mentor for your specific course. Okay?
Okay.
Great. Everybody have a wonderful evening.
Okay, you too, sir. And thanks.